I'm Mr. McBrien. This is TEJ20 BIOS. Before we begin today, I'd like for us to talk briefly about your portfolio in TEJ20. The Ontario curriculum would like for students to be able to demonstrate their learnings around computer engineering by illustrating select pieces of work, showing materials that allow them to demonstrate how much they know about computer engineering. So have a look at the handout around the portfolio. You should be taking pictures of key items related to your learnings. Develop a Google Slides document that contains the most important successes from class. So this might involve working programs, videos of robots, circuit diagrams, and what have you. Make sure that the document has one page associated with a summary of all the skills that you've learned. Make sure individual pages have those specific skills that artifact demonstrates. So let's talk about the BIOS. I like to think of BIOS as the real operating system in the computer, something that maybe is a little less true today than it was in previous years, but I think at the end of this discussion you'll have an idea of why I think that way. So the Ontario curriculum wants us to be able to connect and configure hardware for a personal computer and install an operating system, and we need to understand how to use the BIOS in order to do this. So to understand what a BIOS does, first we need to realize what we don't know. Most people think a computer works in a certain way, and in fact it doesn't. So what do I mean by that? When we power up a computer, we think that the first thing that a computer does is to start loading the operating system. And this really isn't true. In fact, it's much more complicated than this, and we'll understand why in a few minutes. But think of it this way. If the operating system were the thing that powers up instantaneously, were the thing that starts running as soon as a computer powers up, we would have to have that operating system imprinted onto the motherboard. It'd have to be built in. And this would give us a lot less versatility about how the computer works. We don't build the operating system into the motherboard. We use the space on the hard drive to contain the operating system. So the computer has to do a whole bunch of things before it can start to load that operating system. It certainly, one of the key things, it needs to control and extract data from that hard drive before it can start to load the OS. But the motherboard does have a system pre-installed when it comes from the manufacturer to allow it to do just this, to do enough to load the operating system. So it wasn't that long ago that we discussed device drivers. So device drivers control the interaction between the operating system and various devices. So the list is long, but certainly all external devices and some internal devices require drivers. Again, this is another hint as to how the computer works slightly differently than we might expect. Device drivers don't run until the operating system is loaded. But we need some of these things in order to load the OS and do other configuration tasks for the computer. So how do we do that? How do we use the devices that are built in to load the operating system? How do we control the CPU, the various components of the motherboard? How do we address the RAM? How do we control the hard drive, detect the hard drive? Same thing with the optical drive if we want to be able to load things from the CD-ROM. And there's lots more that we have to be able to do without an operating system. If you notice, all of the things we see above, we need to have access to those without an operating system even being installed yet. So this gets us into what the BIOS does. Now, first off, let's declare our acronym, right? It's the basic input-output system of the computer. So this is sort of a mini operating system installed by the manufacturer onto the motherboard before it ships. And it's got lots of functions. Absolutely critically, it gives you the tools you need to install the operating system for the first time. It also will run a series of processes each time you power up the computer. And it'll supervise communication between various components. So the BIOS, in fact, has hundreds of small programs that work to get the computer running smoothly. Now let's move back into history and talk about IBM and their invention of the BIOS back in about 1981. And they decided that the BIOS should be stored in non-volatile memory, a small chip on the motherboard. And the combination of the hardware and software they referred to as firmware. They patented the BIOS in 1981, but they made an incredibly brave decision. And in fact, there were great arguments about this decision when they did so. They decided to make that code open source so that anyone could make an IBM compatible computer. And that decision back in roughly 1980 to make it open source has ripples that continue out 40 years later. They completely defined, well, they helped define the technology world for the next half century based on that decision. So the flow chart of what the BIOS does is quite complicated, and we won't go through it all in detail. But we should keep in mind that it's a sequential process that moves through some obvious steps and some not so obvious steps to get the computer ready to give up control to the operating system. So it moves from that point at which the user turns on the computer, runs through a series of checks, verifications that hardware is available, and then finally at the end, when it has confirmed that everything is working appropriately, it starts up the operating system. So we'll examine a few of these, unpack them over the next few slides. So the power on self-test is essentially the first process after you power up. It diagnoses all of the hardware and peripherals that it needs to run the operating system, make sure it has what it needs to run the operating system successfully. Now, if it doesn't see what it needs, an error message can pop up on the screen to say that a given component is missing. Now, that may seem very effective and useful, but it's worth noting that one of the key things that would be there would be the video controller and the monitor. And so if a monitor can't be detected, in fact, the BIOS, we would still like it to work. It actually uses beep codes, outputting to the system speaker what problem it has perceived. So it'll go through and look for these given components. But it is useful for us to discuss some innovations that came along well after 1981. If we look at many hardware components that are inside our computer and outside our computer, we can see that they have their own integrated circuits and in some cases their own BIOS. So these BIOS memory chips can be detected using what's called a plug-and-play protocol. And these systems can interact and self-define the way that they transmit and receive information from the computer. Essentially, they have an onboard driver. Now, when the BIOS detects components that don't match what it previously saw and stored in the CMOS memory, when the system detects a hardware change, a message will appear on the screen to update, and the system will automatically attempt to update that based on the plug-and-play protocols. Now, after those things have been done, if the hardware is deemed to be effective and configured appropriately, the BIOS will then go to the first sector of the hard drive or other drive that we've designated as the boot drive and look for the boot sector. When it does so, it triggers this program and begins the operating system start routine. In order to have this happen, then there's an operating system kernel which reads into the RAM, and then the BIOS transfers control of the hardware to the operating system. Now, in older computers, in older systems, the BIOS would continue to work as a mediator interface between the hardware and the software. So it would continually run throughout the process of the computer executing functions, and the BIOS would stay active until the computer powers down. Modern operating systems circumvent the BIOS. They communicate directly with the hardware through appropriate drivers. Now, the BIOS is not the same forever, or it doesn't have to be the same forever. So the BIOS can actually be updated. And this we've already mentioned. The BIOS being stored on flash technology, it's non-volatile, but it's not permanent. So earlier versions were absolutely updatable as well. The modern flash system can be updated too. However, this is not something that you should enter into lightly. So if you try to update the BIOS and something goes wrong, you can have serious problems to the point where your computer can be rendered unusable. And it's very hard to troubleshoot. So you want to update the BIOS only when you really have to. Okay, so there are other BIOS chips in your PC. They have roughly the same functionality as the system BIOS. They'll control a given device, and they'll contain software similar to the system BIOS. And they're manufactured with flash technology, enabling them to be able to be upgraded easily. Okay, interacting with the BIOS. Whenever hardware is working well, whenever our computer is working great, we won't bother to interact with the BIOS. It's only when when we're detecting problems or when we want to make changes to our computer that we might interact with the BIOS. If you want to go in and have a look, there's nothing wrong with going into any computer and having a look at the BIOS. You do this by restarting the computer. While it's starting, watch your screen. It'll tell you the key to push, which may be, depending on the version of the BIOS, F1, F10, delete, or even a combination of keys. You press these before the operating system loads, and the BIOS screen should open. Now, if you don't see that key identified on the screen and you can't get lucky and hit the right one, you can always check the documentation for your motherboard to find out which one is correct. Now, once you have entered the BIOS, you'll see an interface which may be a rich GUI if you have a modern BIOS interface, or you may see something like you see on the screen here with some low resolution menu items. You navigate through these typically using the keyboard, but you will find some very useful and interesting information in here. You can change certain settings about the hardware and how it works, change routines. Some of the things you might change, the boot order. So you can change which drives are chosen to boot from. You can change the date and time, change RAM and CPU settings. You can view the RAM that's available, and lots more is contained inside this BIOS menu. If you want to install a new operating system from USB or from a DVD, the system, if it is designed, if it's been set up to load from the hard drive first, you'll find that it won't let you install a new operating system. It'll just move straight past each time, regardless of whether you've got your install disk in the drive. So you need to make changes here to the boot order. Now, when I do this, if I want to install a new operating system, I'll typically go into the BIOS, and rather than change the boot order to put, for example, the DVD first, I will remove the hard drive from the list of boot components completely, and this will allow me to install. Notice that you'll need to use keys to navigate through many of these menus. Okay, so key points from today then. The BIOS is a critical part of your computer's functioning. However, it's rarely accessed directly by users. The BIOS itself is located on the motherboard, typically in flash memory. Prior to loading the operating system, when we power up the computer, the BIOS goes ahead and checks and configures all the hardware that the operating system will need. The power on self-test will check all key hardware, and then the BIOS detects and loads the operating system. Modern computers will then transfer responsibility for hardware interactions to the OS as soon as the OS has been loaded. So for your homework, go ahead and continue your computer build, and if you have the time, have a look at the optional activity, Getting to Know the BIOS. Thanks very much. Have a great night.